All right, so let's go through the classification of amino acids. And I've highlighted the word class within classification for you because I'm going to paint for you a picture of a classroom that is full of 20 different amino acids. And just picture this as the most diverse classroom you've ever seen because each amino acid has their own unique side chain, and this makes them distinctly different from the amino acid next to them. And just like a real classroom full of kids, even though each amino acid is unique and special in their own way, you can start to see that some of these amino acids are more alike than they are different. And we can start to see these similarities in the chemical properties of the side chains. And this allows us to group them together into various categories. And those chemical properties include the charge of the side chain, the ability of the side chain to undergo hydrogen bonding, and also whether or not we can classify that side chain as being either acidic or basic. So the 20 amino acids can be split broadly into kind of two main groups. The first group includes the nonpolar amino acids, and then the second group includes the polar ones. And the nonpolar amino acids can also be thought of as the hydrophobic or water-fearing amino acids. And conversely, you have the polar ones. Those can be considered hydrophilic, meaning water-loving. And yet another way that I like to kind of think about these two main groups are the hydrophobic amino acids. They're kind of like the water haters. They don't really want to interact with water at all. They rather just interact with themselves. Whereas the hydrophilic amino acids are very open and welcoming to interacting with water, and so they're water lovers. And then within the two groups of nonpolar hydrophobic and polar hydrophilic amino acids, you then have a further breakdown into subgroups. And those subgroups include those amino acids that have alkyl side chains, aromatic side chains, neutral ones, acidic ones, or basic ones. So let's take a closer look at those amino acids that have alkyl groups as side chains. And as you can see here, we have 7 different amino acids, and I've just drawn out the side chain for you. I've left the rest of the molecule out just to fit everything in here. And we have glycine, alanine, valine, methionine, leucine, isoleucine, and proline. And proline is the exception. I've drawn out the entire amino acid there because, as you can see, its side chain forms this interesting ringed structure with the amino group in the backbone of the molecule. So I just included it there for completeness. So all of these side chains are made up of alkyl groups, with the one exception being glycine, because its side chain has only a hydrogen atom in it. But because it behaves similarly to an alkyl chain side group, it gets lumped into this category of amino acids. And whenever you see an amino acid with an alkyl group as its side group, you should be thinking that this amino acid is nonpolar. And so they're also going to be hydrophobic. Now let's take a closer look at those amino acids that have aromatic groups as part of their side chain. And remember, we're still under the umbrella of nonpolar hydrophobic amino acids here. And so I've drawn out for you here 2 amino acids, phenylalanine and tryptophan. And what should you be thinking when you're looking at these amino acids? So besides thinking, oh, those amino acids must smell really good because they're called aromatic amino acids. Well, that might be true, but you should also be thinking the same thing that you think when you see amino acids with alkyl groups as their side chains. These amino acids that you see here are also nonpolar and hydrophobic. And that kind of makes sense because aromatic chains are also just made up of carbons and hydrogens. And you weren't wrong if you thought that aromatic compounds might smell really good, because many of our most aromatic herbs and spices that we're all familiar with, like basil or cinnamon and vanilla, are composed of the same sorts of ring structures that we see here. Alright, so now that we've tackled the nonpolar hydrophobic amino acids, let's dive on into the polar and hydrophilic amino acids. The first group that we will look at is the neutral group. Here we have serine, threonine, asparagine, glutamine, cysteine, and tyrosine. The way that I remember that these are the polar amino acids is that these amino acids have a side chain that contain an oxygen or a sulfur atom, which tends to hog all the electrons around them to create a localized negative charge over that atom, and then a positive charge over the rest of the side chain. So you can kind of see why these amino acids like to hang out with water now, since water is also polar in the same way. And these amino acids are considered neutral because although they are polar enough to interact with water, they're not strongly polar enough to qualify as an acid or a base. So which of the polar hydrophilic amino acids do qualify as acidic? Well, that would be these two amino acids here, aspartic acid and glutamic acid. As you can see, these amino acids have a carboxylic acid as part of their side chain, which is a very willing, strong hydrogen donor, which qualifies these amino acids as acidic. When these side chains do donate their hydrogen and they're left in anion form, then in that case we refer to them as aspartate and glutamate, respectively. So you might see them referred to in that way. Last but not least, we have the basic amino acids, and they are histidine, lysine, and arginine. And the way I remember that these amino acids are basic is that if you take a closer look at their side chains, you see a few nitrogen atoms. And remember that nitrogen is a very willing proton acceptor. And this is why they qualify as basic.